In this video, we're going to look at a couple examples where we are going to find some limits of rational functions at infinity. We're going to try to determine if there are any horizontal or slant asymptotes. And we haven't previously talked about slant asymptotes. These occur if the power of the numerator is exactly 1 more than the power of the denominator. So, if the power on the top is exactly 1 more than the power on bottom, then we will have a slant asymptote. And we previously talked about when we have horizontal asymptotes, those will occur if your limit as you approach positive or negative infinity is equal to some number. All right, so here, let's look at this first example. We have a limit as x goes towards negative infinity of x cubed plus 5x squared minus 3x plus 1 over x squared plus 7. So how are we going to evaluate that limit? Well, we can observe the power on top is larger than the power on bottom. Right? And because the power on top is larger than the power on bottom, then we should get either positive infinity or negative infinity, one or the other. So do we get positive infinity or do we get negative infinity? How do we determine that? Well, to decide that, we did polynomial long division. So x squared plus 0x plus 7 going into x cubed. Oh no. Sorry. Going into x cubed plus 5x squared minus 3x plus 1. We would need to multiply x squared by just an x in order to get x cubed. So now we have x cubed, 0x squared, plus 7x. Switch the signs, and combine. Then we would need to multiply x squared by 5 to get 5x squared. Plus 35. Switch the signs and combine. Right, so we have this. So as x heads towards negative infinity, then x plus 5 will head towards negative infinity, and this term is going to head towards 0, and so we should get negative infinity as our output. Now similarly, when we look on top, so we could have looked through this and said, this is our dominant term. As x heads towards negative infinity, this term is heading towards a really large negative value. Down here on bottom, this term is heading towards a really large positive value, but the top value is getting larger more quickly. So ultimately, we have this negative infinity as the output. Now, I went through all this other work, though, because it is necessary to find that slant asymptote. So our slant asymptote is y equals x plus 5. That is our slant asymptote. So where did that come from? Well, that came from this work right here. So in the long run, when our x values get really large, this stuff right here is going to head towards 0. And so the end behavior, the long run behavior of this, is it's going to behave like y equals x plus 5. That is a slant asymptote that we are going to have. All right, so let's look at another example. We have limit as x goes to infinity of 3x minus x squared over x plus 1. And we might again observe that the power on top is that x squared. It is exactly one more than the power on bottom. And so this should head towards either positive infinity or negative infinity. I don't know quite yet which that is. Actually, I have a sense that it should be the negative infinity, but let's just verify that. Negative x squared plus 3x. So we would need to multiply x by a negative x to get the negative x squared. Change the signs and combine. X now needs to be multiplied by 4 to get 4x. Change the signs and combine. And so, if we were to take a look at this limit right here, our limit right here is this term is going to head towards 0. As x goes towards infinity, the negative of x will be negative infinity. So we get negative infinity as an output. We will get a slant asymptote here. Is y equals negative x plus 4. It is this piece right here, because in the long run, this stuff is going towards 0, and so it's going to behave like negative x plus 4. It's negative x plus 4 minus some small value really close to 0. So that's why it's a slant asymptote. Excellent. Now you are ready to do some limits at infinity on your own. So go enjoy.